So in order to use a function, we're actually going to follow a very similar process that we did with the procedure. We have to call it by its name and supply it with any data it needs to do its job. We just have to add a few more pieces to the puzzle. So imagine that you are going to calculate an exponent. So you want to use math.pow of 2, 3. Now if you ran your program, it would indeed calculate that power. You would get a value of 8. 2 to the third power is 8. But it's not displayed. It's not even stored. So we as programmers need to store that result so we can use it. So we might say something like double power, and then down here we might say power is equal to math.pow. And then we can actually use that power variable, system.out.println result power. We've effectively taken that value, we use the pow, which is a function, it returns a result, it only does one job, it calculates that power, and then it returns it back to us. It returns it back to us programmers, so it's up to us to store that result so we can use it for future purposes. Maybe that's just to display it, maybe it's to use it in other calculations, who knows? It depends on the program itself. But if we don't store that result, we've effectively wasted the CPU's time because we haven't done anything with it. We don't want to have to recalculate something every single time we want it. We want to calculate it once and then store it so we can just access the data at a future time. It's more expensive to do calculations than look at a location in memory. So this is an example of using a function inside of our programs. We notice we're doing it inside of main, and our function is way down here below our previous procedure that we created. So all I'm going to do to use calc floor area is I'm just going to replace all of our power variables. So let's say floor area. We're going to calculate floor area. And instead of using math.pow, we're going to use our subprogram, which is calc floor area. Now we can give it any values we want. We could give it 2 and 3, which would give us a value of 6 for our full area. And instead of displaying power, we're going to display floor area. We can still use result there. Now if we ran this, we should get our 6, which we do. Result is 6. So let me go over exactly how this works. So it goes into main as usual at the very top of the program, and then it starts executing our code in a vertical line top to bottom. First thing it does is it defines a variable called floor area. After that, it comes down to the next line, which is trying to assign the value to floor area. However, recall that when we do an assignment statement, it must fully evaluate the right-hand side. It must get the value of the right-hand side before it even attempts the assignment statement. So we're actually safe doing this, because this whole thing is going to be effectively replaced with whatever the result of calc floor area is. So we jump in, when we get to this line, it's going to jump down to calc floor area, way down here. It's going to copy 2 into length and 3 into width. Then it's going to come inside, so it's just defined 2 new variables, length and width, that are now stored in memory. It's defining a third variable called area. It's then calculating the result of area using our new length and width variables. And then it gets to this return statement. Now, this is a little bit morbid, but this is the way I like to visualize it. We know that our data is deleted as we end our subprograms. What I like to do is I like to visualize somebody jumping off a cliff, and as they're jumping off the cliff to their doom, they're throwing the data back to somebody that's standing on top of the cliff. In this case, that somebody is you, the programmer. So that's throwing the area back over the cliff, and you're going to catch it, and you're going to store it somewhere. In this case, we're going to store it in a floor area. And then all the local variables down inside of calc floor area, length, width, they're all deleted. So I can't access any of that data anymore, which is why I have to store it. And then I can display it however I want. Now, just like we did with output user info, I can put anything I want in these parameters as long as it satisfies the contract, 2 doubles, double length and double width. I can get that data from anywhere. Maybe it's a variable. Maybe it's from the user. Maybe it's from another subprogram. It could be anywhere. As long as it's a double, that's all that matters. Okay? Now, looking at these two, comparing the procedure versus a function, we can see that there's really only 2 differences. Procedure always returns a void. Function always returns a data type. It might be a double, it might be an int, could be anything, but it is a data type. Then inside, the second difference is that a function also requires a return line. And the rule is that the value that's being returned must match the same type as the return type in the signature line of the function. So if I'm calculating the area of a floor, I shouldn't be returning back Steve. It doesn't make much sense. Right? So we have our calling of our subprograms. We can get that data, as I said before, from anywhere and anything. What I wanted to emphasize is one last little bit about the data inside these subprograms. Now, in the past, we've told you that every variable must have a unique name, and that's true, but only if it's in the same scope, and this is where things are going to break a little bit. It's still advised that every variable you create has a unique name. You see here that we have floor area. Down here I have area. So yes, they are both two different variables, two different variable locations, two different memory locations, but more so they actually have unique names so that we know which is which. As programmers, we can easily see that. But there is times where we may need to deal with both global data and local data at the same time. And I'm going to try and illustrate this point using our procedure here. Now imagine I created a variable inside of here called username, string username. And I gave it the value Frank. Doesn't really matter. And instead of outputting name down here, I'm going to output username. Good. But imagine I have a global variable way up here, static string username. And I'm calling this one Billy. We're giving it the value Billy. Now the question is, when we call this line here, system.out.println, which one is actually being executed? Which username is it referring to? Is it username Frank, or is it username Billy? Well, let's test it. Let's modify this. Instead of using username, let's use user age, because user age is something more mathematical. It might be easier for us to actually see. So let's give this a value of 10. And up here, we got to change the string to an int. And up here, we're going to have an int. We're going to have user age. And we're going to give this one the value 5. Now imagine down here I say user age is equal to user age plus 1. So the question is, I'm going to put this back to name. The question is, what is going to be displayed on the screen? Is it going to be 11 or is it going to be 6? 5 plus 1 or 10 plus 1? Well, let's run our program. We have to actually call it. We're not calling it up here. Output user info. Bill. Oh, yeah, Bill and 27. Now when we run our program, we see we get Bill and 11. So the name gets copied. So Bill gets copied into name, which is what's displayed. 27 gets copied into age, but we're not displaying age down here. We're displaying user age. User age is defined here and here. A global version and a local version. We see as a result we get 11 though. What that tells us is that when we use a variable inside of a subprogram, it's always going to use the local version. It's always going to use the version that was created inside. But what if we wanted to access that global version? So for example, you might be creating a game that has, like, you might have a subprogram that's modifying a score and doing some math on it, but you don't want to make changes to the overall score of the game until you're ready. But you want to be able to work with both within the same subprogram, and if they're both named the same, you may run into complications. Well, we can do that by referring to the keyword this. So I could say this dot user age and this dot user age plus 1. Now it's complaining right now, and the reason why it's complaining is because I have that keyword static in here. So you can't actually do this technique inside of a static subprogram, which means it's not going to be a lot of use to us inside of our standard Java programs. Where it will be a lot of use to us is inside of our game programs, where we're not working inside of the static main, we're working inside of our other subprograms like update and draw, which are not static. But we can refer to global data using the keyword this. This refers to this class. So this class level variable called user age. This class level variable called user age, add 1 to it. When we display this on the screen, we're still just getting, we would still get 11 because we're referring to the local version here. I would have to actually put this dot to get the global version. So this is only useful in non-static circumstances, but it is very useful in those occasions. Okay, so what we've done here over the last few slides is cover a large amount of information with respect to functions, procedures, subprograms in general, parameters, scope, and there's a lot to go on here. So get to work on the practice work and make sure you get this cemented in your head very well, because this is going to be one of the most useful concepts you're going to learn in foundational programming, and probably one of the more challenging ones. So don't be afraid to come back to the videos and check again. You're probably going to have questions. Thanks for your time.